Hello friends, in today's video, let us learn about Coulomb's law. This law helps us to find the magnitude of force of attraction between two unlike charges, the magnitude of force of repulsion between two like charges. Thus, force between two charges is attractive if charges are unlike charges, and force between them is repulsive if charges are like charges. Coulomb's law can be studied in two different forms. First one, the Coulomb's law in scalar form. Second one, Coulomb's law in vector form. Coulomb's law in scalar form. Statement: the force of attraction or repulsion between two point charges at rest is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them. Now, to understand Coulomb's law in scalar form, consider the two charges. This is the first charge and the second charge. The magnitude of charge is Q1, positive charge. So it is a positive charge. Present charge on the body is a positive. And it is a negatively charged body. And charge on this is a Q2. That is a minus Q2. Now, irrespective of the symbol, either the plus or minus, we take here only the magnitude. The mod of Q1, that is the magnitude of first charge, and mod of Q2 nothing but magnitude of the second charge. So the force of attraction between the charges F is proportional to product of magnitude of first charge and product of magnitude of second charge. Let us call it as the equation number 1. And F is inversely proportional to square of distance. What is the distance between them? The distance is r. So we are taking the r square of the distance between them. So let us call it as the equation number 2. Now what you do now, you combine both the equations. So F is proportional to product of magnitude of first charge, product of magnitude of second charge divided by r square. Now to remove this constant of proportionality, what you do? You remove the constant of proportionality and write down over there k. So k into magnitude of first charge, magnitude of second charge upon r square. So what is k? K is nothing but electrostatic constant of force. You can also call electrostatic force constant. So what is K? K nothing but electrostatic force constant. And this equation, that is F equals to K into magnitude of Q1, magnitude of Q2 divided by R square, nothing but called scalar form of Coulomb's law. K value is constant. It is a force constant. But it is always not constant. It changes with the medium. If the medium is changing, the K value is also changing. So for air or vacuum, the value of the K in SI system is given by 9 into 10 raised to 9 Newton meter square per Coulomb square. Let me repeat. In CGS system, K equals to 1. And in SI system, K equals to 9 into 10 raised to 9 Newton meter square per Coulomb square. Thus, electrostatic force constant depends upon the nature of medium separating two given charges K value also depends upon system of units. Now, K value depends upon the medium separating two charges. If the charges are placed in vacuum or air, then K equals to 1 upon 4 pi epsilon naught, where epsilon naught is nothing but called absolute electrical permittivity of the free space. And if the charges are placed in a medium other than vacuum or air, then K equals to 1 upon 4 pi epsilon, where epsilon nothing but absolute electrical permittivity of the intervening medium. Intervening medium means the medium which is present between the two charges. The medium which is separating the two charges is nothing but intervening medium. So if the charges are placed in a medium other than air or vacuum, then K equals to 1 upon 4 pi epsilon. Now let us talk about Coulomb's law in vector form. Before we proceed further to understand Coulomb's law in vector form, let us make a little revision about vectors. What is a vector? Vector is nothing but physical quantity in which we talk about the two things. What are the two things? One is the magnitude, another is the direction. Magnitude, the value associated with the physical quantity. For example, 10 kilometers per hour from north to south. So this 10 kilometers is called magnitude. When the body is moving from north to south is the direction. So a vector quantity 1 is associated with magnitude as well as direction. Now let us consider two charges placed in the xy coordinate system. After this, we join origin and q1, origin and q2. We get two position vectors OQ1 and OQ2. OQ1 is a position vector of q1 and OQ2 is a position vector of charge q2. Let us assume the charge q1 is placed at the point A and charge q2 is placed at the point B. Therefore, vector OA equals to vector OQ1 equals to, let us assume, equals to vector R1. Similarly, vector OB equals to vector OQ2 equals to vector R2. So vector OA equals to vector R1 and vector OB equals to vector R2. Now join A and B. So we get vector AB. Vector AB can be obtained by formula vector OB minus vector OA. Vector OB nothing but vector R2 and vector OA nothing but vector R1. Let vector AB equals to vector R12, where vector R12 is nothing but vector leading from Q1, charge Q1 to charge Q2. Similarly, to find vector BA, vector BA equals to vector OA minus vector OB. Vector OA nothing but R1, vector R1 and vector OB nothing but vector R2. Let vector BA equals to vector R21. Vector BA equals to vector R21 equals to vector leading from charge Q2 to charge Q1. So we have vector A to B is vector AB, and we have the second one, vector BA. And vector AB nothing but we have taken R12, vector R12, and vector BA nothing but we have taken vector R21. Now let vector R12 cap is nothing but unit vector in the direction of vector AB, and let vector that is a R21 cap nothing but unit vector in the direction of vector BA. Coulomb's law in vector form can be studied in two ways. One for like charges, another for unlike charges. Let us consider like charges. When two like charges placed near to one another, they repel each other and move in the opposite direction. Both charges move in opposite direction due to two opposite forces. First one, vector F12 force on Q1 due to Q2, and another force vector F21 that is force on Q2 due to Q1. Now R12 cap, that is a unit vector in the direction of AB, is equals to vector R12 upon the magnitude of R12. So magnitude of R12, vector R12 is nothing but R1. We can call it as a R also. So let R12 equals R, implies R12 vector equals to unit vector, that is a cap stand for unit vector. So R12 cap equals to vector R12 upon R. Let us call it as a similarly vector R2 cap, that is a unit vector in the direction of BA, equals to vector R21 upon magnitude of vector R21, that is R21. Magnitude of vector R21 equals to R21. We can call it as a R, so it is equals to R. Therefore R21 cap equals to vector R21 upon R. Let us call it as a equation number 2. Here we also notice that distance AB equals to distance DA, and let us call it as a R. First of all, we will find out expression for force F21. That is nothing but force on Q2 due to Q1 in vector form. F21 equals to, by using Coulomb's law, 1 upon by epsilon naught Q1 multiplied by Q2 upon AB square multiplied by unit vector in the direction of AB. That is equals to 1 upon 4 pi epsilon naught Q1 Q2. What is AB? AB nothing but R, therefore R square. Unit vector in the direction of AB, that is nothing but R12 cap. That is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and R12 cap is nothing but vector R12 divided by R. Therefore, F vector F1 1 upon 4 pi epsilon naught Q1 Q2 upon RQ multiplied by vector R12. This gives expression for force in vector form. This is nothing but Coulomb's law in vector form. Similarly, F vector F12 equals to 1 upon 4 pi epsilon naught Q1 Q2 upon RQ multiplied by vector R21. And we know that from basic formula, vector AB equals to minus of vector BA. Therefore, vector 21 is nothing but minus of vector 12. From above discussion, force on Q1 due to Q2 is equal to force on Q2 due to Q1, and both forces are directed in opposite direction. Thus, Coulomb's law agrees with Newton's third law of motion.